All right, just wanted to take a quick few minutes here to go through how to use various packages with Melange. If you are working in ReasonML and using the Melange compiler, this is sort of what you'll want to know to get up and running. Two things you should know off the bat. First is that NPM is available to you, so basically anything in the JavaScript ecosystem, because you're compiling JavaScript. But also, since ReasonML code is basically OCaml code in disguise, you also have access to OPAM, the OCaml package manager. What you're going to be looking for in a lot of cases should come from this. This will be your easier experience when you are bringing libraries in from here typically. Whereas things you bring from JavaScript directly, you are going to need to write bindings for if they don't already exist, so there's a little bit extra effort there. That's a topic I plan to cover in the future. It won't be part of this video, but just be aware that it's there, and know that you can go to the Melange documentation to get more of an idea on how to do that in the meantime. So, to get started, I have created a repository from the Melange OPAM template. I have renamed everything. I have a separate video out on this whole process and getting started from scratch if you need it. But once you've renamed everything and initialized everything, you should be looking at something roughly like this. This is the end of the init process over here. And to make sure everything works, you can now run a make watch, which will compile everything, watch for changes, and recompile as needed. And then a make serve. Let's bring that one down here. Okay. And when you run into weird issues like this where you're getting LSP errors, just do a restart language server first and see if it fixes it. It often will. Yep, I have syntax highlighting, lovely. From here, what we're going to want to do is begin using two Melange libraries. Now, let's go this window. There we go. So if we come in here and we go to packages, and we search for Melange, there's not a ton of options, but there's some already here. And these are two that we want to go ahead and start working with. The first one is melange-fetch. It's going to let us work with the fetch API to actually pull data from, various places, other websites, whatever. And the second one is melange-json. When you're working in a strongly typed language, but you're bringing in, untyped data, which JSON is effectively untyped, you do have to tell the language sort of how to decode it and how it should try to work with it. That's what this is going to handle, and then this is going to make fetching easier. So let's start by opening up our OPAM file. And in here, we're going to want to add two extra lines inside of the depends section. This is your dependencies. I'm just going to paste these in. The first one is melange-fetch and version at least 0.10, because that's what we're doing. Second one is melange-json, at least version 1.0.0, because that's the latest one out. Once you're done with this, you can come over here, kill the make watch, and run a make install. I'm going to speed the video up at this point because this part will take a minute. And there we go. Everything is installed. If we run another make watch here, whoops, make watch, we should see everything compiles. This is still working. If we come over here and make a change with melange, we should see it reflected over here. Lovely. Now we can start adding our actual fetch call. So I'm going to start by adding this. This will give the URL that we're going to pull from. This is something on my GitHub repository. You're welcome to use it if you would like. And then I'm just going to go ahead and copy and paste this next part just because it's going to take a minute to type it out otherwise. We're going to replace our existing make function in our app module with this, and I'll walk through it in just a second here. But when I do this, you're going to notice that it immediately fails saying unbound module fetch. What's going on here? Well, you've installed the packages using the package manager OPAM, but you haven't actually told the build system, which is Dune, how to use them. So if we come into the Dune file that's inside of the source folder here, we have an area where we do that, which is the library stanza. If I come into this and add melange-fetch and melange-json and save, now our compilation errors go away and everything's happy again. And in fact, you'll notice now we've got a header where do we go? Here we go. Header that says colors. And then we've got some text, which is just our fetched response being printed to the screen. And that's happening because we're saying perform the fetch, take the text version of our response, assuming it worked and everything, and then simply set that in this colors variable. Now, that's not doing a whole lot of useful stuff on its own, so we want to do a little bit more. What I want to do first for that is I'm going to create a new file called color.re. I'm just going to paste this in and then we'll go over it. What this is going to do is it's going to have a type within it so that we can tell our type system what's going on. And that type contains two properties. One is called name, which is a string. One is called hex, which is a string. And if you look at the data here, you'll see that we have a name and a hex value and two more sets of values being provided for every color that we have here. Now, I'm going to ignore these two values at first, and we'll add them later just to show you kind of how that works. So let's just start with this, which is why that's all we've got here. And the decode function is telling melange-json how we would like to decode this. So we say basically I've got a JSON object that I'm taking as my input to the function. I'm creating a return object. Actually, you know what? Let me get rid of this curly brace and this curly brace. They're not needed. Because we don't have any more things here than just the one line effectively of information, we can omit those. Now in here we've got json.decode dot, and what this is doing is this is opening up the JSON decode namespace so that we don't need to prefix everything in here with json.decode dot whatever, right? Semantically, I could get rid of this and put it in front of field and string in each of these cases and it would be the same thing. This just makes it a little bit shorter. So we're going to go that route. This is our function for decoding. Lovely. Now if we come back here, we need to actually tell it how to decode this, right? The way we're going to do that is first by changing this from text to JSON. Okay, it's going to cause an error because now we're returning JSON data, which has its own special type and is not just a string. But over here, we're attempting to take a string and use set colors, which because of the type system says, hey, this needs to be a string because you gave me a string up here, and we get an error. Now, we no longer want to use a string up here, so let's start by changing that. This is just an empty array. It's not going to fix the problem yet because that's still not right. This can't just be an array when what we actually had here was a blob of JSON. So we're going to do an extra step. Now, this step can just be inserted right in the middle like this. And what this is going to do is it's going to say, hey, we've got JSON as of this then. We're going to come in here, we're going to take that JSON, we're going to pipe it into JS-JSON decode array, and this will return an option of an array of JSON data. Now, it's an option because it could fail, and technically this is not the right way to deal with that, but for the sake of this video, we're just going to keep this real simple. We're just going to say, hey, give me whatever's inside of that option, or throw an exception, okay? Now, once that's done, we actually have an array at this point, which is why we can now map over the array. And what we're going to map over it is our decode function from the color file. So this is going to say for every item in this JSON array, attempt to decode it using these decode rules. And then at the end, we're going to resolve because this is a JavaScript promise. Same thing down here. That's where these resolves come from. You may notice that this is a pipe operator and this is a pipe operator, and it's a little bit odd having them mixed and matched like this. Personally, I prefer this version up here, the pipe last operator, but belt uses pipe first as its semantics. So when you were working with belt, you will need to use pipe first a lot. We're going to come back in a few minutes and change this to a different library that prefers pipe last, so just kind of ignore the fact that this is all goofy right now. And let's also change this because it's no longer text, so it seems a bit odd to call it text. And we'll just do that. Okay. Now down here, we can't take this array and just say react.string, right? It's not just a string that we can do that with. So So we're going to change this. Actually, I think I can just, yeah, let's just get rid of that whole tag. So we're going to delete that, replace it with this. And let's change this. This should actually be belt.array.map. And let's make these both be the same pipe. Okay. So now we're saying, given our colors, right, which is our state variable up here, we want to map over the array. We're going to look at the each color in the array, and we're going to deconstruct it here into its component properties. So there's a name property and a hex property, right? We want to take both of those and make them easily accessible down here. We could do, you know, color up here and then access the properties with like color dot whatever. This is just a little bit cleaner, I find, so I'm going to go this route. Now, once we've got those values, we're going to make a div tag. And this is, again, for every value in the list, right? Going to make a div tag. It's going to be a flex container so that we can put these items underneath side by side. First div is just going to display the color for us, and then the second will display just the name of the string, okay? And we're displaying the color using the hex value that we decoded as well. So this gives us a nice little list of the colors and what they actually look like. And could be on its own exactly what you need to get up and running if you're trying to, you know, fetch data and display it and everything. I want to get a little more in depth with this just to sort of show a more complex scenario. So we're going to go over here. Let me grab this first. I'm going to change this color file a little bit, and it'll cause a compiler error. We'll get to that in just a moment. But first, notice that we now have a couple of modules in here, one called HSV, one called HSL, and then they are referenced by their values here. So if you remember earlier when we looked at the raw JSON data, it contained a name, a hex value, and then two objects for HSL and HSV, two other kinds of ways of representing colors. And this is basically going to say, here's how those all work together for the type system, here's how you decode them. And I wanted to include this because this is important to understand if you have objects within objects in JSON, sort of how it can work. And so in this case, it's saying HSV is not just a string or an integer or some kind of a basic type. It's actually a complex type defined up here, right? Type T for HSV has hue, saturation, and value. And then type T for HSL has hue, saturation, lightness. Represent them with the types that are up there. Decode them with the decoders that are up there. And that takes care of that. Now, the reason we have a problem over here now is that we are attempting to destructure this, but we're not destructuring everything out of here. For clarity to the developer, you kind of want to actually say, hey, there are more things here, but we want to ignore them. And you can do that like this, with a comma and then just an underscore, and that'll say ignore all of the other properties, but sort of know that they're there, okay? Now, I actually want to access one of them. So let's come back over here. Once again, I'm just going to copy and paste. Let's do this right here. Yep. So if we do that, that will give us the HSL access to hue, saturation, and lightness values. Now, the compiler is not happy because we haven't actually used these, so that's perfectly fine. We're going to use them in just a second. And I'm going to do that by just replacing this line like this. So here's what's happening with this. We're saying, you know, do a p tag for whatever p stands for that I can't remember right now. And in it, we want to put a string. And we're doing a string builder here. I'll explain in just a second. And then piping to React string because it's a string. The string builders in, not string builder, I'm sorry, string interpolation in Reason can look about like this. You can do curly brace, j pipe, and then at the end pipe j curly brace, and anything in here is going to be the same sort of string interpolation you might deal with in JavaScript itself for the most part. These values will automatically get converted to strings for you and everything. And so what we're doing is we're just saying, hey, let's list out what we're going to print and then print them out. And you can see the result over here, which is right name red, and here's your HSL values for red, green, and your HSL values for green, etc., etc. You could do the same thing with the HSV values. We could also use them in some meaningful way if we wanted. For now, I just wanted to sort of demonstrate this part. Now, at this point, I've kind of jumped over a little bit how we're using the different pipes, pipe first and pipe last and everything. I want to go ahead and fix that by replacing the default library. Well, in this case, I want to replace belt, effectively. By default, you have two libraries at your disposal. You have the OCaml default libraries, and you have belt. OCaml libraries do prefer pipe last, but they have some different problems with them. There are some... we won't get into it. Anyways, what we want to do is replace these with a library called relude. Now, relude is a library that was originally created for ReasonML while it was still on the BuckleScript compiler. And you will probably run into this with a lot of libraries where it was created for ReasonML while BuckleScript was the main compiler. But BuckleScript is no longer maintained or updated. The ReScript project sort of went a different direction with it, and BuckleScript kind of died at that point. The melange compiler is your replacement for it, but it does have some different semantics, hence kind of the point of these videos, right? And as a result, the libraries being converted over to it are not all going to be in the right state to use them the way we just did with melange-fetch and melange-json. There's some extra work that still needs to be done on them. Relude is an example of this, and you could, if it was just a one library by itself that you needed to do this with, you could actually come in here and say relude and give it the version of the library you want to use, right, 2.0.0. And then you could come down here and say pin depends, and we could tell it that we want to pin this dependency. And that would look something like relude.dev, and then the Git repository that we want to point it to. Now, I'm not going to do that because relude itself has a dependency on another library that is also in process of being updated, and you can't just pin a library that has a transitive dependency on another library when they're both in this state. What you can do instead, though, and this is a bit odd because you'll have to do this once per machine, what you can do is instead is say pin opam pin add -y relude.dev and then the GitHub URL. And what this is going to do is pin relude to that repository, and it's going to take the relude transitive dependencies, whatever kind of dependencies they are, and it's going to pin them as well. And so Bastet is the library I was talking about that relude depends on, that's still in this sort of weird state. This will take care of all of that. So you can see it's installing Bastet, it's installing melange-json because relude needs it, and then it's installing relude. All right, I'm going to speed up the video a little bit here because this will take a minute. Just kidding, it's done. And once that's there, we actually want to switch over to using it. Now, first off, how we would do that is take out this belt.option.whatever, and if I go right now and say relude.option.getexn, this is the equivalent command. This is going to fail because we haven't actually added our library reference yet. So let's do that. And we need to start our make watch again. And then unbound value option, not getexn, option.get or throw. There we go. Let's go ahead and restart the language server one more time since I did not get my auto completion on that. Let's try it like this. .get. No, still not getting it. Okay, we'll come back to that. Now, what I wanted to go to next, I'll come back to why that wasn't auto-completing in a minute, but what I want to go to next is that right now, the way we have this set up, in order to use relude, we do have to prefix everything with relude dot. That's not going to be the behavior that I actually want in this case. So if I come back into the Dune file here, and let me grab this line real quick, we're going to want to add an additional stanza here. You can add it right at the end of your melange.emit, and what it's going to do is it's going to say, hey, we've got some compile flags, we want to open the relude.global's namespace globally. Okay, so we'll save that. And now if we come back over here, we can actually delete the relude dot, and it's going to work the same way. Now, here's where things are going to get interesting, because if I get rid of this and just go to the relude array, right? If I control click on this, you can see it goes to relude array now. We're going to get an error. And what's going on exactly is, let's see, this has type JSON T of array, but an expression was expected of type A to B. So it's looking for a function, but it's getting an object. Why is that why is that happening? Well, because the map function for array says give me a function and then give me the data upon which to operate. Whereas belt.array.map says give me the data upon which to operate and then give me a function to map over it. So if I put this the other way around again and start changing our pipes to actually match pipe forward, or pipe last semantics, everything will be fine. Because what's happening is the output up to this point is being sent as the last operator to this function. It doesn't matter for these other functions since they all only take one parameter, but anything that takes more than one, you'll start to notice this behavior. We have to either do pipe first or pipe last and kind of figure out how we want to work with it. Okay, so with that in mind, let's come down to this one here, change this to be pipe last, and then change it to be the relude array. And we'll need to do one more here because this should also be pipe last. When you mix pipe first and pipe last operators, there's a precedence issue that can make it a bit unwieldy and strange and everything. If you're doing something, just try to stick to the one kind wherever you can for that exact reason. Curly brace, space, curly brace, and change this to that. Okay, so now we shouldn't have any more pipe first operators anywhere. There's one more here. This one technically doesn't matter either, but we'll just change it. All right, so now everything's using pipe last. And yeah, that's pretty much it. This has been a rough walkthrough on how to add and start using libraries in Melange. I do intend to dive a bit further into various parts of this video later on, such as things you might use relude for, pipe first versus pipe last, and more advanced library usage topics, such as using OCaml libraries that were not necessarily built for Melange, but can still be used with it. If any of those topics interest you, or for more videos covering various ReasonML, Melange, and OCaml topics, please consider subscribing. Thanks for watching.